it's good to have you here. Greg, how long have you been associated? How many years?
Or was in this building. Well, the no one definitely.
It's got to be 4, 5. Yeah. Anyways, one of our own, amazing. He's just the go-to of knowledge for almost everything that I can think of. So anyways, we're lucky to have him. And again, for those that didn't see a video last time of Carson, I apologize. There was a mix-up in noise, but hopefully we'll get those slides and then we can put it out at least on the Forge channel, because I'd like to make sure that that is preserved. Because anyways, all right, I'm just going to leave it up to Greg to take over, and then you'll just go when you want, whatever. All right. Thank you, Greg.
Hopefully I'm on the hotspot now, because hopefully it'll be a little more free. So I think most of you know me, but my name's Greg. I'm actually a customer engineer at Google Cloud. So this is technically part of my job to do these kinds of things. Today, we're going to talk about workload identity and federation, which is basically saying, you shouldn't need to use security keys, or you shouldn't need to use service account keys anymore. There are better ways of doing authentication, be it through GKE or through Kubernetes in general, or even cross-cloud, hybrid cloud stuff. So we're going to see what we can find there. Most of the stuff I'm going to talk about is about GCP, just because that's the one I know. All the clouds have this. This is not a GCP specific thing. You likely can do this even between services you're using. So be it GitHub or GitLab or all the different things that you're using that have their own identities. We'll see some references to them, but I'm kind of going to go deep on the Google side since that's the one I know. I had actually given this at B-Sides as a shorter version of this without a demo. I think there's going to be plenty of time, so we'll even do hopefully a quick fun demo at the end. But since that was a cybersecurity conference, it's kind of going to start with a bit of fundamentals on cloud security, a quick run through that. Service accounts, application default credentials, maybe you've heard of these, maybe you haven't. Workload identity and identity federation are the two tools that we'll spend the most time on. A few best practices, won't dive too deep. A lot of links, so you can reference these slides if you're ever like, I know we want to be able to do this. There's great blog posts that cover kind of the specifics you might want to do, and then that demo. So I don't know if you can actually see this, but that is an AWS credential file, GCP service account key, and Azure login just sitting in a directory, right? Some people here probably get really stressed out when they see this, especially that last one. Anytime you see private key, you probably don't want that just hanging out anywhere.
Could you go up just a little bit?
Just a little bit more, actually. I hope you recognize that you're maybe taking on a little bit higher risk profile than you need to. These are the crown jewels. These are what white hats and black hats are looking for, because once they find them, they can be used to dig deeper into your infrastructure, steal company secrets. Mine Bitcoin is the popular one. Literally within seconds of one of these hitting GitHub, someone's probably mining Bitcoin with it. So definitely watch out for it. If you see these, think that there's probably a better way to do it. Sometimes it's the required way of doing it, but 9 out of 10 times you probably could get something equivalent without ever having to expose secret information, even to your local file system. Like, oh, it's in my local file system, it's secure. Well, you're one exploit away or one bad decision away from having these just show up on access to it. That's the reason for this talk. It's to hopefully help you understand that you see those and think of a different way. So quick overview of the fundamentals. In GCP, it's identity, roles, and resources. This is going to be similar for others as well. Those arrows are what we would call role bindings. But like identity, it could be a user account, it could be a group, it could be a service account. Roles is just a group of permissions. We'll see that in a bit. And then resources is all the things you actually want to use. All the cloud resources you're planning on trying to use within your organization or someone else's organization. This doesn't actually have to be within your org. A lot of times when you're doing cross-org stuff, do they have to give you a security key, or can I just use my current identity to go and make a claim against something that they've authorized me to be able to access? Some types of identities. So users are usually humans. That's an actual person, likely a developer, administrator, kind of interacting with Google Cloud or whatever it is. Service account is more of an application or workload. So you've assigned a set of permissions to a service account. That account gets attached to various things. Kubernetes has its own version of service accounts. Within the cluster, they have their own RBAC and their own resources and roles and things that need to be done. So they have their own, they're called KSAs for shorthand. Group, of course, just a list of a set of people. All users. So Google Cloud has a couple of these that are like, they sound like you maybe know what they are, but you probably want to be very particular when you're using these. All users is literally everyone, authenticated or unauthenticated. Very few times that you want to use that unless it is like a public endpoint that yes, everyone should just always have access to. All authenticated users, you might think that's your org's users. No, that's everyone with a Google account, including someone that signs up right now, goes and uses it. You grant permissions to that, everyone with literally on the internet just got access to it. So definitely make sure you avoid those when and where possible. You always want to make sure you're scoping down to least privilege, least amount of people that need access to something. Roles and permissions, we mentioned this. So in Google Cloud, we come with a very small set of basic roles, so like owner, editor, viewer. I use these a lot in demos just because they're always there. They're easy to kind of start with. You probably don't want to be using them too much in your environments. There's also predefined roles, so they're more granular. They're based on job function or like target service. So like storage admin means everything you can do with Google Cloud Storage. Even better though is just build your own roles. Like you probably don't need all of the permissions of storage admin, even if what you're doing is administrating the storage. Like you probably only need certain things, especially when it comes to service accounts. Like unless it's literally Terraform that's using this, and in that case, maybe that makes a lot more sense. When it comes to an actual application, maybe they only need write, maybe they only need read, or like, do they actually need the ability to create a new bucket? You definitely want to kind of build those roles to custom fit the applications. I believe there's tools now that also help those be like, hey, you know, like here's the 1,000 permissions that are granted. You only used 15. Click a button, maybe you know, you'll get a custom role out of it. It's a much better way to kind of build that long term. In Google Cloud, we have organization as our highest structure. I believe Azure, it's a subscription. AWS, it's account. They have maybe some like meta layers above that, but that's kind of how it goes, unless it's changed on me in the past.
I think management group.
Management group. No, so the actual like highest level. So you have management groups above subscriptions now.
Yes.
So is that like the because AWS did something too, right? They have like a watchtower or something weird, like
management groups. Then you have subscriptions under that.
Yeah, I don't think Google Cloud has anything above organization. There's a billing account that kind of floats off on the side that gets associated with things. But organization, that's it's actually your domain name for the most part. So it's kind of where identity gets rooted. There's folders, projects, and then actual resources. The reason this is important is your privileges that you can do as a identity that has certain roles bound to it is the accumulated set of permissions that are granted at all levels. And so it might make sense to grab things at a folder level. You have a prod folder, a dev folder. Like that's a great place to kind of anchor things so that all the projects underneath that kind of inherit that permission. Oftentimes, those will be platform teams that manage those, and then individual application teams are going to manage kind of the lower level things because you know, they're closer to it, and security fights them at the higher level to make sure they're not doing anything they don't. That security doesn't want them to. I'm so glad you're here. He's secure, so or at least was. I don't know if you still do. Service accounts are actually unique. They are both identity and resource. So an identity of the service account can be granted, say, instance admin on VMs, compute instances, but a user could be granted a special permission like service account token creator role on the service account. So it can actually use that resource to generate tokens and impersonate service accounts. So always need to kind of, it makes the bindings extra fun when you're like, okay, well, this is for a service account. Is it the service account that needs the permission, or does something need that permission on the service account if you're talking about impersonation? Just an easy thing to mix up. There's also multiple kinds. So the one most people are familiar with are Google managed keys, where like we just generate the keys, we rotate them, you know, you don't have to think or care about it. There are some circumstances where it's actually better for you to generate the keys. Maybe you have an HSM and you want to have private key information stored in that HSM. No human being ever sees this. It's just something that you can generate and then use to like sign tokens when needed. At the user managed key, you only upload the public. We never get the private key. Google knows nothing about this service account other than how to validate tokens that are representing it, or kind of like the cryptographic signature stuff. That's a very secure thing. It's used for things that need to be super secure. It is now on you to rotate those keys and to do, you know, make sure it is maintained in a secure manner. So we don't see it often, but you know, it's available. It's there for those kind of cases. Often, actually, OIDC signatures and stuff. This is an area that may make more sense to use Application default credentials. So when you are running in these environments, maybe you just want to access to something like I'm on a VM. Why can't I just use that VM's, to find my credentials? That's what ADC is designed for. It's actually a very explicit ordering of places that it's going to look, very well-known locations. Things like an environment variable, which is kind of like, hey, just go here. This is where I want you to get credentials from. If you use G-Cloud auth login, you're going to get access to whatever keys it stored when you went through that process. It stores them in your user directory, your config directory. And then the metadata server, you've probably seen that before. There's a metadata server for VMs. There's actually a special one for GKE that we'll talk about in a bit. Whatever gets attached to that VM is going to be what the metadata server serves out as its identity, at least by default. You can actually ask it for others. I believe you can have multiple. I've never seen it. This is what the process by which applications don't have to have hard-coded keys. They'll just start trying to find them. And as long as one of these hits, then you'll be on your. And we mentioned short-lived. So when you extract a service account key, that is static. It is going to last as long as that key is valid. I don't think most keys even are expired by default. You have to actually explicitly set a key to expire. If you lost it or someone hacked the laptop and scraped it off, hopefully you knew that happened or found out that happened, because if you don't, that key's just there and it's still valid. Much better approach is short-lived credentials. All of these things that we talked about, the metadata server, even the G-Cloud auth login, there is a long-lived refresh token that exists there, but all of the keys that it's getting are much shorter-lived, usually down to the point of sometimes 10 minutes. Every 10, you get a job or a token, it's valid for 10 minutes. If that gets lost, yeah, it sucks. But if it was lost on the wire and they try to use it, they only have 10 minutes until it starts expiring. And your account, your local application just gets a new token automatically in the background and keeps refreshing it. And if someone was able to get one of those, it limits the blast radius significantly. So definitely something you want to go for. Whereas if you just have it as a service account key and you're cramming that in your application, that's long lived. That is not something that expires. It might call out to a service and get a short-term token from that, but by default, whatever that extracted key is a very long. So what does ADC look like? Well, here's just some Python code. When you use the cloud SDK libraries, it goes through that ADC process and just says, oh, well, is there a JSON config file or a exported service account key waiting for me in an environment variable at some path? If so, it's just going to use that. If not, then the well-known location on the file system. Or the metadata server. That's kind of the last one that it usually tries. It's often the one that that works in GCP, that works in AWS has their version. You could technically build your own metadata server if you give it the right name. And I think you can't, because it uses a host name you couldn't get a cert for.
I don't think it's HTTP. I think it's HTTP because there's networking VM silliness that means you never leave the machine, right?
It's a link local address.
Yeah, exactly. So
yeah, that's right. It is link local. They do require you use a special header. So if you had tried to do an attack from a browser to be just fetch this, unless you can inject that special header, metadata flavor GCP or something weird like that. It's not a normal HTTP request that you could maybe just redirect from somewhere else with the DNS hijack. It does require at least one special header. It's not a secret header. It's just hey, if I don't see this, it probably isn't coming from a valid request.
Yeah, the earliest implementations that I saw doing what you're leading to with Workload Federation or Workload Identity, AWS, we were doing this in Kubernetes, the AWS, where you ran a metadata service in Kubernetes and then did network silliness to get all your pods to talk to it. So you can fake it if you intended to fake it.
Definitely. Well, and I'll show you. So after this talk, you don't even have to fake it. This thing is wide open. It's technically even documented on the Google API dev standards. It's just, this is how we do auth. And as long as you follow that process, then all's good. So what about GKE clusters, or what about on-prem applications? So for GKE clusters, workload identity for GKE is what it was called. And if you're going hybrid multi-cloud, is workload identity federation. I like this better as BYO-ID. You have identities, they're strong. We'll just use those. Why do we need to create new IDs if you already have? Of course, we like rebranding things. And so now the thing that was easier for me to describe is now slightly harder in that it's just Workload Identity Federation for GKE. It's a couple extra words. It's actually using the same stack. Like it makes sense why they did it. It's all OIDC under the cover. But you'll see that I still use the old term because it's just what I've used it forever. And it's easier to differentiate than like, oh, did I add the for GKE or is it for Azure or for AWS or for Workload Identity for GKE? Basically, because Kubernetes has its own strong identities rooted on those Kubernetes service accounts, the previous manner of doing it, and what you're probably most familiar with, is you would use that to impersonate a Google service account. That also changed in the rebrand, which we'll see in a second here. But pods that were had KSAs would get annotated to just say like, here's the thing you should be impersonating. So the application owner just says, yeah, go use food service account in certain project. And then through the metadata server, it kind of just makes everything work. So you did have to create something called a workload identity pool. That's actually the place, that's the resource where you can do IAM policy binding, where you can kind of do all of these things. You'll see a URL that comes out of identity pools. You would then also have to grant that pool or the KSAs that flow through that pool the ability to impersonate the GSA. Like that's not something you just get. It is an explicit requirement that you have permission to generate tokens for a Google service account. And so you had to do that. See, it's grayed out here because you actually don't have to do that anymore. And then the policy binding. So like you're now a GSA, like it needs permissions to do stuff, right? Like it needs to be able to go and do a cloud storage operation or whatever. In the new world, which I think is literally from May, so Google service accounts are based off of what's called Gaia identities. That's Google Accounts Identity Management, I think, Gaia. But like Gaia is the thing that you've used forever. It's literally your Gmail, your YouTube, your everything at Google. Everything supports Gaia. For the past about 2 years, they've been trying to get everything to support what we call Ubermints. And so an Ubermint is literally a mint that works in this OIDC world. It isn't based off of a something email address style thing. It's like, oh yeah, you had an identity, we anchored it on a workload identity pool. That's now the claim that we're kind of passing through as a subject or username, whatever you want to call it. And you should grant permissions directly against that. So whereas previously you had to do this, like create a GSA and then do the permission stuff and member service account with this funky, not that one, the further down, so like the workload identity user permission had to be granted to this funky service ID Google namespace KSA name thing. And then you annotated the thing to kind of like make everything go through. A lot of those steps are gone now because what you can do is just through that workload identity pool have what we're calling principles. These are IMV 2.0, which I didn't even know we had, but that's apparently what it is. Google Cloud IAM 2.0 has principles, and principles are a lot more structured. And so it's something like a URL that lands on a identity pool that has a subject with a namespace and a KSA. Now you're granting whatever your target permissions were, cloud storage, admin, or whatever it is, directly against that KSA. You don't need to do an impersonation step. There are caveats, the biggest one of which, this link at the bottom is a whole bunch of caveats. It's actually a list of a whole bunch of services saying no caveat, no caveat, no caveat. And you'll find one like huge caveat of like VPC service controls. If you're using that, they do not understand permits. They understand Gaia mints. So if you're trying to do a perimeter ingress policy on a VPC service control, if you don't know what that is, blessings. If you did know what that was and you need to do that, that only works with Gaias right now. Eventually it should work with permits. It just takes a long time to get that across. So it's kind of cool. Like it removed a few steps, and it does mean that literally you're just granting things directly against the identities, although it's the identity reflected through this. You can't actually go directly to AWS. You have to have something on our side that we anchor.
Maybe this is just a blind spot with me on both of them. Looking at the new one release shows me something I'm missing. The binding is at a project level, Kubernetes namespace and KSA name. What if I have multiple clusters?
So if you have workload identity pools, you can have one pool per project, and projects usually will take this via a fleet. So either it's the project that the cluster lives in, that's the pool you get. There's no alternative. You can't just be like, pick another project unless that other project is a fleet project. And fleet projects, fleets in general, and GKE is all about sameness. And so again, we're saying like this service account name in this namespace for this project is the same across everything that this gets attached to cluster wise. Clusters are not pets. You can't give them names. You can only name the workload at any pool that gets attached to them. And therefore everything that comes out of that has to be the same. And you cannot explicitly grant permissions to a pod. Pods don't have identities. Pods have service accounts. And what we're saying is even service accounts don't have identities on the cluster level. They really only have identities when anchored into the project or the fleet project.
And that must still be true. Is that the same kind of policy as it was if you were doing this? Because we're doing this thing on the left,
Yeah.
but
So
it's not as obvious on the left that
this
you
project
do this
ID,
in
right?
one project.
So service account : project ID.svc.id.goo. That represents the workload identity pool. On the other side, it's a longer URL, global workload identity pool, and then that same thing. And so like literally everything up until that point is like just identifying the pool. Everything after that is identifying a namespace and a named KSA inside the cluster or any cluster that gets that pool of identities. You can still do the impersonation. So like if you want to do impersonation, you can see, I think actually you would use this principle. So this same member on the side here, and then the same permission on the impersonate. So like you would grant IAM workload identity user role against the principal. You could use the old method too, but like I think what they're saying is like long term, IAM 2.0 is using these principles. There's a doc that shows a whole bunch of cool things you can do.
So maybe you're going to get into this, Greg, but where's the auditing or the actual, just when you said fleet and the capabilities, that's just like, you just, you're.
Yeah. Nothing changes. So like IAM is still doing all IAM's things, right? And
So you still have the same old auditing, same old.
And what changes is previously you would recognize email addresses because every IAM is based off of an email. And so now the identity is going to look like a URL. Right? But it can be a lot more expressive with that too. Some of these get really crazy because it's not just the subject. You can be like, well, it has to have this subject, but also this claim and stuff like that. So see how those look. But yeah, principles are much more expressive than the old email based. So yeah, this is, that this kind of gets to your point of like, well, what if I have multiple clusters? Well, anything attached as part of that pool, and you can only ever attach to your projects pool or a fleet. Fleets can have a dedicated pool just for like you can have a dev fleet and a prod fleet, and then that way you can attach whatever clusters you want to those. But those are the only two options that exist right now. And then you may want to do this node selector, which is like, so by default, like VMs get the GCE metadata server. You don't want that one. Once you get into this world, you want to make sure you're scheduled on a node pool that is using the GKE metadata server. So that's the selector that can do it. Or there's policies that just be like, don't ever allow anything to not use this. This one's definitely more secure for that kind of like multi-tenant workload. Then GCE metadata server was designed when it was just VMs. And we'll see some other cool things that you do with that too towards the demos. So that was all, GKE workload identity federation. Well, what about like, hybrid multi-cloud? I have on-prem servers that I want to grant things, permissions to in Google Cloud or AWS or Azure. I'm using AWS or Azure, and I want to be able to make calls across cloud. We call that workload identity federation. The main thing to look out for is we also have workforce identity federation. That's for actual humans. That's for people that are going to interactively log in and do things. You don't want that for your workloads. Workload identity is the one that's for actual workloads. And it's still using all the same stuff. So like we didn't explicitly really mention it on GKE, but this is all based on OIDC. OIDC is something you use on a daily basis. Like literally every login page you ever go to is pretty much based on OIDC. It's really good at separating the identities from like the things that need to validate them, and then it just passes a bunch of claims over, and then it's like someone else. It's the other side's problem once all that happens. And here's that in graph form. So you're going to have an application do an auth request. it's going to land on the server, and the server is going to say, oh, well, I know, how to try to validate this. It goes back to what's often called an OpenID or Open OIDC discovery endpoint. And that's just like the collection of all the key stuff that you need to be able to do the validation. Once the validation has occurred, like, yep, this is fine. Now it's like, okay, does it have the right subject? Does it have all the claims that I'm requiring to be able to pass through this? If all of those checks pass, then a token would be returned, either an ID token or an access token. I don't know that I can even easily describe the differences, but access tokens is what you're usually using. That's the one that's usually comes out when you use like G-Cloud auth login. Just like, I have a token now, this is the thing I could shove in a bearer header and start making Google API calls or calls against something that is just using like a REST API. If you saw Carson's talk, he did a whole talk on JOTs, and it's way better than what I have time to do. But JOT's just a bunch of JSON. It's literally assertions inside a JSON object. There's a few of these that are standards that are part of OIDC. You can cram whatever you want in there, whatever makes sense to send over the wire, so they can make decisions on the other side. Go for it. This one was actually GitLab, although it looks like it was generated by Audience Vault, or at least is intended for a Vault server. And yeah, there's plenty of ways of doing this. Usually you're going to have some IDP, you're going to have something that does this. Kubernetes has these built in. So for the demo, we're actually just going to use K3D, its OIDC provider, and see what we can get done. But yeah, pretty easy to understand. It's all jumbled up in like some cryptographic signature. You actually have to use a tool to extract these to make them readable. But once you do, it's pretty readable. The nice thing about this is they include so much information. You could be like, oh, well, I only want to allow this if it's being generated on the main branch by the runner for CI/CD. Like, that's the identity that you're anchoring to. It's the identity of the worker, but also the stuff that surrounds it. Like, if they're on a dev branch, like, no, they can't access our prod GCP on the dev branch. They can only be done on the prod. Two modes, and this will be important during the demo. So if it is a public endpoint, there's just a public place to look for it. So .wellknown/OpenID configuration, that's the place that's going to give you a bunch of information back, one of which is a URL for a job key set. And that key set is what will have the public key. That's all you need to be able to do the validation. So if it's a public endpoint, then great. It's just going to try that. It knows where to go to get this key information to do the verification. You could take that key information, it's just another set of JSON, and you could just shove it on a web server somewhere. It is important, the URL sometimes. On our side, we actually require that the issuer matches. We're only going to go to the issuer. Some of them will be like, yeah, you're telling me what to do, just tell me where the job key set is and it'll accept anything. I don't think ours does. But maybe it's offline. Maybe this is air gap. Like, maybe this token came out of somewhere, but you're never getting back into it. Nice thing about cryptography, it's all math. So if I can just take that key set and put it into my pool, it will know what it needs to do. And until the keys rotate, which sometimes, some of these last 10 years, honestly, ours only last like 14 days. So like, you probably don't want to do that with, our keys. Our key, if you really want to make sure you have that live access to the refresh key. But in other cases, the K3D one, I do think it's like a 10-year key that it generates. So until the cluster gets pwned and someone did a key recreate operation, or just deleted the cluster and recreated it, got brand new keys, that static set of information is going to be just fine. A few best practices here. So definitely you want to use those attached service accounts. The attached service accounts give you all the great stuff of like, you get the kind of anchor identities and permissions into something that's easy to comprehend. Like, yes, you could do this against everything. Sometimes it still makes more sense to be like, okay, no, here's our prod file uploader service account. Anything that needs that permission should impersonate it, right? That way you get not only one log that says this user or ID impersonated this service account, but then you see, oh, well, we're accessing this storage bucket, but we're doing so through a very well-defined service account that only has permissions to do 3 things. And so like, you can kind of ignore it. Like, oh, I don't think that's causing any problem because I know it's a very reduced set of permissions. You'll actually see one of these is also centrally creating those. I know a lot of security teams, like, they just lock down one project. They create all their service accounts there. They do cross-project permission granting. It makes it very, very easy for them to be like, no, we know this one is secure. There's not like some Joe Schmo in there fucking around with stuff because it's shared with a prod project or dev project. Like you can kind of separate the identities around into its own project, which is nice. Your own service account keys or like extracting those statically and storing them on disk should be done only as the last resort. There are definitely some times that it is the only way to do things. When you do that, it's now on you to do the rotation. If those ever leak, like hopefully you caught it, because if you didn't, they're just in the background. You literally can't tell them different from anyone else that's using that key. Also things like that ability to actually upload service account keys, that's probably a pretty specialized permission. You don't want everyone to have that. Your security team probably should have that. And then maybe you deny that permission from anyone else, or hopefully they don't have those permissions even to begin with. And I mentioned VPC service controls. That is like an identity firewall around Google APIs. It literally lets you say like, hey, this project has these storage buckets and we don't want stuff ever leaving this perimeter. And that perimeter might include some VMs. It might have attached projects that like it's expected. But if someone from Russia comes in and tries to do something, it's like, whoa, like, yes, we're on the internet, but you're outside my perimeter that's been defined and I'm not going to allow you to do access. Makes your life much harder because like things break much faster and easier. Like even the console, your laptop trying to use the console might break unless you've explicitly said, oh, well, if you see egress via this IP, have that classified as something that I'm then going to allow access. So it's a very advanced thing that should be on your list, but not the first thing on your list as a startup. Definitely more towards when you're the target of nation states. That's the kind of thing that they'll use to help solve it. Org policies, I'm not going to spend any time on this just because this is like even more in the weeds than the other one, but there's a lot of things that you can do at the org level to enforce this. So like security teams love org policies because they can just be like, nope, this never happens in our org, or at least outside of this, one or two exceptions. There's a huge list of them. I put a couple on here that might help show what they're useful for. So like disable cross-project service account usage. Yeah, that probably is something you want to do for some of your projects, and that's just literally something you turn on. And then now it's enforced for all time, and it's going to bite you later because somebody's like, well, why can't I do this? And I'm like, because we said you can't do that, and you got to find a way around it. So cool stuff there. They're always adding to them. I've heard there's potentially custom ones coming at some point too. So this is kind of well into the vein of like security teams doing advanced security things to protect the cloud.
So it looks like, I mean, these are very granular.
Oh, yes.
Do you find where you have to be careful when they're not so granular?
I think what ends up happening is one, hopefully they're granular at the right level where like 90% of your projects, you're fine. Just be like, yeah, that totally doesn't make sense for these to exist there or for these users or for whatever it is. When it gets to super fine grained things, I know for me, what ends up happening is like, I go and do stuff and like make stuff happen. And eventually it stops working. I'm like, what happened? Oh, we have something called an enforcer, and so an enforcer is watching all the audit logs. And if you need something more fine-grained, you can write your own code that just sucks in every audit log session of everything. And if it's okay for it to exist for like 10 minutes or however fast you can see that log and make a decision on it, that's the way that you get as fine-grained as you want. Is you literally just write a bot that watches everything that happens, and whatever you trigger on, it's like, nope, we saw you did something that we don't allow, so we're now shutting your project down or whatever enforcement action you want to take. So, but then also like let us know what required you to go to that level, because hopefully we can find easier ways of doing a lot of things. But that's putting him out of a job, so maybe don't do it. Do it. Yeah, he wants it to. And so here's all those additional resources, right? So like these are all just a bunch of links, enabling that keyless action from GitHub Actions. That's probably the first one. I'm hoping everyone, if they're using GitHub Actions, that was an easy thing to enable. That's like one of the first features that people end up using this for. Same thing for GitLab, AWS to Azure, or Azure to GCP. We have a big doc for that. Deployment pipelines, that Terraform often needs to do stuff. So like, how can you make it work there? There's a couple really good blog posts around at least the pre-rebranding workload identity stuff for GKE and fleets. We're going to see the fleet stuff in the demo, so dive in there. That principal identifier, so we just open that up because that's a cool one. So here you can see it's 2.0. This is all old busted now, I guess. But so like service accounts now start with principals, right? And so like this is what previously would have been that service account : now it's principal : URL. You'll see a lot of this is like, well, we anchor on something on our domain, and then it's like, well, is this a regional resource or a global resource? Service accounts, they're global, they don't even put it in here. Whereas sometimes you'll actually end up seeing like, well, this could be regional, this could be global, so there'll be like a location / global. Principal set is just a group, so this is that one of those identities that we talked about before, goog/public : all. I guess that's what they picked it to be. It's maybe more descriptive than one it said before, so I can't wait on there. Principals in the cloud identity domain. So cloud identity accounts are different than workspace accounts, so sometimes that matters. All identities in a workforce identity pool. So workforce is the ones that are humans. I actually like that they separated out humans from workloads. That's a nice thing to do. They definitely have more things going on there. I can validate those identities. Single identity in a workload identity pool. We'll see this in the demo. That's the member that I'm going to grant permissions to. All, sometimes you're like, oh, actually, like things that come through this pipe, like I know where they came from, and like we're going to make, it's that public thing, but it's only public for relevant identities. This one, I don't even know what it's used for. Deleted. Like you can grant permissions to deleted identities.
I read this as granting permissions to a specific instance of that identity. So I've created Kirsten.Anderson, whatever. I know it has this ID.
BYO-ID, maybe
if someone deletes that account and recreates it with the same name, that won't apply anymore.
It may also be that like, hey, once something's deleted, they're now a whole new category of like deny everything. And like, maybe you're just literally saying like, as soon as you're deleted, here's all the things we're going to block you from being able to do.
It's a knocking over the door, I know.
I've never had to use it. I have questioned why it's there that I hope I never have to answer.
That'd be some very specific reason.
That's likely to be a lot of questions. So with that, like, who wants to see a demo? I don't think I've actually ever done a demo on any of the meetups here too. Like, so it seems like a rough thing
To fail.
So I went through it, like, and this is a fun one. This is literally from like, if you want to make a pie, you gotta create the universe style. It's so workload identity federation testing. So let's start with nothing. So demo at local host. Okay, so Docker, yes, no containers, right? Nothing on my sleeve. And then I guess G Cloud, this one doesn't matter. Off list. Okay, not logged in anywhere, right? On this laptop, I'm going to create a cluster, and then I'm going to use pods in that laptop, like workloads running on my laptop. I want it to access a GCP bucket, but I don't want to inject keys or anything. I literally want it to use identities generated from this laptop to be able to do so. Let's see what that looks like. So we're going to create these kind clusters. If you've never used K3D, it's a great tool. It just helps you create these little Kubernetes and Docker clusters. Right. So this is spinning up a bunch of containers in Docker to make a Kubernetes cluster and do so pretty quickly. It's a K3S cluster. Yeah, that works really well. So you did notice I had to do something here where I'm literally passing arguments to the Kube API server. They harden it to turn off anonymous access. We need that if we want to be able to hit those endpoints without JOT tokens. So I'm turning it back on. And so now Docker PS, we have a Kubernetes cluster. It has a K3D test server 01 and then some load balancer thing. Let's see what pods it has. Okay, get pod. A. So this is a K3S cluster, right? Has core DNS, some Helm Traefik stuff, so that must be how they're doing the load balancer, local path provisioner if you want to use some volume stuff. Metric server, another Traefik, right? So I'm still kind of starting up. Still give it some time to do stuff there. I could run this. So like this is just a container that has the G Cloud command in it. If I ran this in the cluster and did an off list, there's nothing in there either. Like that's easy to understand. Let's see what it did do though in terms of identities. So here is using kubectl. And if you never use kubectl raw, that's basically like, hey, go through all the kubeconfig file, get my identity and all the stuff I've been granted to be able to do. But now let's just like make raw API calls against kube API. And so that well-known OpenID config endpoint that we talked about is what it looks like. This is me still authenticating, like there was a bearer token involved to get there. But you can see the issuer. Issuer looks like, oh, well, that's the Cube DNS name for the Cube API. JOX URL. So this looks like probably a Docker IP. That's 6443. This is where it says that I can get the key set. And so let's actually see that key set. And I'm going to save it away. So I am going to need that.
You're saying that all just happened automatically.
That's all K3S. Like that's kind K3S, K3D. If you ever need to do any testing with Kubernetes, use K3D because you can spin up 10 clusters. It'll fill out your kube config file. This is all running locally. It works really, really well for testing API stuff like controllers and stuff. It doesn't work so well. Like this is all running on my laptop. It's going to run out of resources really quick.
K3D didn't spin up the issue. That was K3S that has the.
Kubernetes
It's
API
built in.
Yeah.
has endpoints for OpenID.
So normally if you're running, so like this is trying to pretend that like I have a big on-prem kube cluster. You're probably going to pick a different identity provider. You're probably going to go through the docs for Kubernetes that says, here's how you take the key cloak, name your ID key. And that's what you want all your identities based on. It's probably going to have an issue that goes to key cloak because that makes much more sense. But Go can do this just as well as anything else. And so when it's just a silly little kind cluster, the Cube API server can be an issuer for. So it's literally how it creates the KSAs and all of the tokens that it uses. Is it's just using OIDC. So this one doesn't do anything. Let's keep going here. So now that was from using kubectl with bearer tokens. What happens if I try to just call it against, where I told this API server to live? Failure. So forbidden user anonymous can't get path. Well, I turned on anonymous auth, but that doesn't mean everything's available. There literally is a role binding that has to be created. So let's create that role binding. Okay, so now I created that role binding and ta-da! So now a public user, no bearer token, just curl against a REST API, which is what Cube API is. I can now get that same information back.
Show us that file real quick.
Yeah.
Like, hold on, what does that look
Yeah, go be the YAML.
Go to this URL, it has everything, you got permissions. It's a role binding.
like?
So cluster role binding, I grabbed this, I think off Stack Overflow for the group unauthenticated cluster roles. There's even a defined role for this. It's so common to say, yeah, the cluster role of literally discover. So it's this, if you describe this role, you'll see that it's just like two URLs. It's literally the two we're trying to use, and it says, yep, allow it.
So, I mean, how would you know that if you didn't know that?
I mean, there's plenty of GitHub.
Oh, I know, but I mean,
And what happens is, so if it is a different ID provider, so like if I'm using Keycloak, this URL still works, and it just returns the Keycloak JKS set, right? It's like, it's all the mechanizations of like, how do we just make this system work with all these parts that can be like swapped out, right? And so like, we still haven't done anything here. All this is doing is like, how do you get a key that you can use to validate a job that represents a service account? That's all that this is, doing so far.
Creating this file is your only actual change to the cluster so far. Everything else is showing.
And, this flag to the API server because K3D or K3S by default hardens itself to prevent this. I think GKE doesn't right now. That's the weird thing. Start running this against your clusters, your endpoints.
Well, it's still to give permissions, right? So it's like, yeah, you can
So I
do nothing anonymously. So
don't know if GKE prevents that permission by default or allows it. Because like, what are you getting out of this? You get a public key that has no use except for validating jobs. So it's not like it's a insecure thing. There have been security incidents for things like this. And so like hardening the cluster and like K3D choosing to have it off, anonymous auth turned off. Literally there's a flag to the API server. They're just like, nope, never turn it off. We don't need it. Everybody will always have a job. Okay, that's probably the right default.
it's probably not uncommon to run K3D clusters with just people turning RBAC off entirely. And then if you do that, then it's probably good to have on arms off as well.
Even more fun. So like this is still only accessible on my local machine, right? What's that? That's a URL item, demo.a through z.dev. Well, I just shoved Cloudflare D tunnel in front of this. And so like now my on-prem thing that I want to be able to, kind of have everybody in the outside world would be able to access this and validate my tokens and my strong identities. That's how easy it is. I'm sort of lying because Google can't until I can change this to match that public URL, right? Like this cluster.local, that doesn't exist. They can't call into that. So I'm going to have to take the route that we talked about of just saving that JKS set and telling the identity pool how to use it. There's probably another flag somewhere. I just didn't have the time to find it. There's literally a flag that says service account issuer. And I think that's probably the one that I need to do. But like setting up an actual IDC, like twiddling more of that was well beyond. But that's cool. Like literally anyone on the internet can now hit this and my identities can be validated. They just can't do so and match the issuer, which is a requirement for some of these, like Google pools require that. But yeah, so like we have an on-prem Kubernetes cluster. It can't do much, but it's there and it has OIDC, it has strong identities that we know how to validate. So let's do some more fun stuff here. So this is my project. We're going to go into IAM and the Workload Identity Federation section. This. And there's nothing here. There's no pools, nothing up my sleeve, right? So we're going to run this command to create the tool. In fact, I'll just run this one too, and then talk. Actually, while it's doing that, I'm going to sneak down here and run one that I know. So pay no attention. I'm just running something that has to download some files that I'd rather not have to leave. It's not download. Let's figure that out. So let's refresh this page. Here. Back to here. So come on. Oh, what caches to? Oh, it had a pair of it. So I don't. Oh, I know what I can do. I can run these on here. So G-Cloud command to create a pool. I want a new issue. So this one is authenticated with Google. And if I run this, it's using my personal credentials to be able to create it. I tried deleting it and it said, oh, yeah. So I think this is actually something that once you create, you can delete to disable it, but you can't recreate it. That's why there's something here that says hidden. See, I just learned something.
The one that like we keep this for 90 days.
Maybe something like that. So like show deleted pools, right? So here's the one that I used before. Oh, and I can say, it says deleted.
Demo 2.
But so yeah, now I have demo 1. And if you look inside of it, so a pool can have multiple ID providers. I guess I didn't complete that. Here's the ID provider, and you can see it has this temp thing. Oh, then I need to change something else. So next. Now this demo 1 thing has to go here. Here, not you. You. That. Requested entity was not found. Where else did I miss that? Create demo provider global 1. Oh, it's to be on project. That Now, it's it. Okay. So we have this demo pool one. It has a OIDC provider, and if we look at it, most of this stuff doesn't matter too much. Issuer, definitely important. This is where, had I been able to get that to be an actual public URL, we wouldn't have had to inject a file that says, here's my keys. It'll just go to that well-known endpoint whenever it needs keys. They can be rotated however fast you need them to. That would have been fun, but I can figure out how to do it in the time that I had. So instead, I just literally in the command uploaded the JSON file. Audiences is like, what do I want to allow? Audiences is something that's kind of advanced, but like the main issue with these tokens is like, what if you're a service that accepts tokens and you just replay them somewhere else? Well, audience says like, hey, I'm creating a token, but it's only for you. And so this is where you could say the tokens that are for me must come with an audience that says gcp.a-c.dev or federation.a. You can kind of make up whatever you want, but it's how you can orchestrate it. So like, well, when I generate these tokens, I know they're only going to be valid for this service because that's the audience that they're going to. And then there's this insertion stuff. So like, what is the Google subject for this, the JOTs that come through? Well, it's going to take the assertions.sub. We haven't seen one of those yet, but we'll see it in a second. And it's basically, well, we did see it on one of the slides of like, sub is a standard assertion in a JOT. So it's going to take whatever that is and pass it along as the new identity, the new Google subject for this. Yep. So that's all good and gravy now. Next here. So some other things you can do. So like if you had excluded that path, it would have just defaulted to calling the well-known endpoint. You can also pass -- disable. So if you want to create it but not actually activate it, just something you can do there. I already applied this. We'll see that in a second. In fact, what does this look like, right? So here's a workload, test namespace, service account. Interesting thing here, auto mount false. What does that mean? Well, it used to be you would always get the JOTs for your service accounts in Kubernetes. They just show up somewhere randomly in your file system. The new way of doing it is, well, maybe you don't need that. Maybe you want a specific token, a token with an audience. And if that's the case, you can actually make the control plane and the kubeless life a little easier. Disable that. Don't auto mount something for me. Part of my desired state, I'm going to tell you what kind of token I want and where I want it. Config map. What's going on here? Well, I need to tell the Cloud SDK what to do, right? So this is going to get mounted into that Google application default credentials environment variable. It's a JSON file, and this JSON file tells like, where do I find my token? Where do I send it? And what do I want to go through all that process? So the audience stuff here, right? So I'm setting an audience to the actual OIDC provider that I created.
Change that.
I'll need to no, because demo OIDC provider, I use the same name. I didn't. You can delete the providers, you just can't delete the pools. So this pool right here, yeah, I need to add a 1 here.
Yeah, that's what I was saying. Yeah.
Token. So this is where I say I want a token type JOT. I think you can actually specify ID. So if you actually need an ID token, you would change this line. This is just a URL that is where you send and receive tokens from Google STS API. There's a whole REST API that will tell you things you can do with tokens for that. And then source. Well, like, yeah, it's going to be a file. I'm going to have a file in my pod where I'm going to get my token. This could be a number of different things. You could have made it out of sort of like, go call this HTTP endpoint at this path with blah, blah, all this stuff, right? There's a lot of different credential sources, and I'll show you, it's actually this link here will create cred config. If you're like, I'm in Azure, I'm using Entranta or whatever the frick they're calling it now. So like, you want to generate a config for that, we'll help you get there. And if you do still want impersonation, there's still a step for that. So like you add this section in, and it's just another endpoint, IAM credentials endpoint, where you could then say the actual service account and saying generate access token, right? It doesn't mean I have permission to do so, but at least knows this guy I'm going to take from here, I'm going to blah, blah, and like shove it here, and out will pop out then the diamond instead of a new permit. Pod, it's just a bare pod. I'm using that big image, which I really hope was downloaded. Here's that environment variable that I'm setting, right? So I'm just setting this to where I'm mounting that config map. I'm also mounting my KSA token because I'm explicitly having to do that because I told it not to automatically do it. Here's those volumes, right? So I can specify my audience on my KSA token. I can specify the expiration, and I'm just mounting that config. So before I forget, let me go and edit. So edit -n testing config map. My cloud SDK config. All I need to do is add a number. Should be. Oh, hey, there's an annotation for that.
I think so. I've seen that before.
Okay, so I edited that. Get pods testing. Yes, it's running. It's such a big image. It's literally the same image is used for Cloud Shell. So but it has all of the tools that I know it. Yeah, so let's jump in there. I'm in my bear pod that has all the stuff that I wanted to have. Let's look. This is still all local, right? Like here's that config map that we just saw. Here's my token. This is my KSA token. So again, this is just what K3D created. Let's see what that looks like. JWK. Yeah. So something you should never do with real tokens.
Website, any website.
Yeah. Technically, this happens locally in the browser, but still.
Well, yeah, as long as they code browser code.
I'm sure it's only in the browser.
Well, it's for a demo, and plus, also right now we haven't given this any permission, so like I feel pretty safe here.
You can do it with grep and
it's only valid for 10 minutes. So if you can write that down in 10 minutes. So we can see the audience that I specified. It's in there. There's some expiration issuer stuff. It does have this whole BYO Kubernetes IO section that includes information. We are not using that. We could in our like assertions or stuff. Like we could totally add additional things here. The only thing that we are actually using is this sub, right? So system service account testing, which is the namespace, and then the KSA name, which is G-Cloud KSA, right? So this is still just what Kubernetes gives us out about this. Literally, as you're passing stuff through Kubernetes, this is what you're passing. You're passing this job. But we just told Google how to validate that job. So here, this is the thing that if it works, I'm happy. If it doesn't work, then it's empty. But I'm going to ask G-Cloud. I'm going to ask the G-Cloud command to authenticate using my default credentials and printed access token. And it did. So what this means is it took that JSON file, it knew what to do with it, did all the things that I told it to do, and out popped a government token that is very valid for anything in GCP that it has permissions to do. What does it have permissions to do? Right now, nothing. And even worse, I don't think I know how to make G-Cloud use that. It's an issue where like G-Cloud itself can't actually use application default credentials. You try to log in with it and ask you for like a password. What's that even mean? We're going to install Python and we're going to go back to like the Python code that we were basically looking at before. That's a pretty easy thing to look at, right? So I'm going to import the packages. I tell it which project I want to use. I instantiate a project or the client, and I'm going to try to print sort buckets. What's going to happen here? Oops. In Python 3, print buckets. Oh, I don't have permissions. Well, of course I don't have permissions. I didn't grant any permissions.
you have identity.
I have an identity, and it made it all the way through that. But last step is using that member principal with the same subject, that we saw before, and of course, changing this to be demo 1. This demo. Here, add 1 there. This all the way to the end. I'm going to go to my shell here. So this is the is another way. So this is, if you have never seen the Cloud Shell, like this is just the shell in that project. So I can definitely use it to grant permissions. So I granted the permissions. Go back, so for storage bucket, print, I have one bucket. So my local laptop and the identity that was literally created by the cluster that I created 5 minutes ago just got permission to list buckets in Google Cloud Storage. Technically has admin permission, so you can do anything else you want. I think that's pretty cool.
Awesome.
Yeah, that's really
Right? And that's it. That's all I have. So.
Wow.
So happy to answer any questions. Literally part of my job is like, if you wanted to do that in your cloud environment, you know, hopefully if your account team can help you, we jump in and help. You can see the slides. It's actually really not that hard once you know all the pieces and where they need to go. But yeah. So glad when you didn't go through, I was like, but I was like, I couldn't figure out how to delete the thing either. It's like, why won't it just let me delete? And then why is there a, oh, it's because probably reuse there is also pretty sketchy. Because if you deleted it and then someone else came in and reused, they're global, right? And so like, I did this in my project, and if someone else had access to a different project, but took the same name, then it probably.
So since the model is a zero trust, I mean, is it really zero?
So it's zero secrets that had to be exposed, right? So when I mentioned you can create service account keys and never send them to Google, that sounds weird, right? Like, why would we let you do something, but like, why don't we get the private key? It's like, well, because you don't trust us and you don't even trust the person that generated it. Like, you're going to have a literal machine whose entire job is to generate secrets internally, never expose them, use them to sign or do whatever you actually need to do with those keys. And like, everything has to still work. And so that's, yeah, like he has one in his bag, right? I'll figure it out. But like the one you have in your bag is the consumer version. Like there is enterprise grade, like where do you think your Bitcoin wallet is, like the rooted chain for that? Like, yeah, it's somewhere that like takes 5 people's YubiKeys to even get close to getting in. And even then, like hopefully the ideal case is the private key material never leaves the device. There's an API to sign stuff with it, and maybe a policy on what can and can't be signed with it. And then that way it's like, there's just encryption at all corners preventing bad things from happening.
Well,